Hello children, we are going to discuss a sample paper which is related to IGCSE Physics Edexcel. Okay, right. We start with question number 1. The photograph shows a brass mass. State the formula linking density, mass and volume. So I assume you can remember these things when we have learned, but it's not a harder question, it's a very easy question. So the way you do is this. The equation is the density is equal to the mass divided by volume. Okay, so if you write in symbols, rho is equal to MOV. Okay children, right. Next question is part B. The brass mass has a mass of 154 grams. Density of brass is 8.46 grams per centimeter cube. Calculate the volume of the brass mass. Give the unit. So that's a simple question. Just substitute into the equation. So when you substitute the equation, density is 8.46 grams per centimeter cube. The mass is 454 grams. I'm sorry. Where I set this? Okay. 454 grams, and volume is unknown. So the volume will be equal to, change the subject of the equation. So you get 8.46 grams per centimeter cube. So when this sum, the grams and the grams get cancelled off, and what is remaining is per centimeter cube. When per centimeter moves to the numerator, so then you get the answer as 'll use a calculator. (454) divided by 8.46, which is equal to 53.6643. Yeah, for two decimal places I can write the answer as 53.66. so the answer is 53.66. the unit will be centimeter cube. Okay children, right. Moving to the next question. A glass contains fizzy water. Bubbles of carbon dioxide form at the bottom of the glass and rise to the surface. The graph shows the relationship between the volume of a bubble and the pressure of the gas in a bubble. So you have learned these things children. Pressure versus volume for a gas having an inverse relationship. But when you see the shape of this graph, you can't say it's inverse or not inverse, right? So I'll explain that later. So what you can say is it's a curve. So it's a non-linear graph, or it's a curve. Next thing is they have a negative relationship. One increases, the other decreases. In other words, it has a negative gradient. The next point is its rate, or the gradient, is decreasing, right? So I'll explain one by one. So first point I can write is when the volume increases, right. When volume increases, the pressure decreases. So we can say this as a negative relationship also. Negative relationship means it has a negative gradient. Second thing I can say is it's a non-linear, or it's a curve. Third point I can say is the rate or the gradient decreases. Right, I'll explain that. So look at several points on the graph. Assume this point. So here the gradient will be very high. Then this point the gradient will be comparatively low. Here the gradient will be even lower. Okay. So what you can say is gradient is decreasing. The gradient is decreasing means the rate is decreasing. If I say the gradient here as m1, here the gradient as m2, here the gradient as m3, I can say that the m1 is the highest, then m2, then m3, right? So m1 is greater than m2, then m3, which means the rate is decreasing. Okay, children? Right, moving to the next question. State the formula linking pressure difference, height and gravitational field strength and density. So that's a very easy question. I can write the equation as delta P is equal to delta H rho G. Okay. Delta P is equal to delta H rho G. To say the correct equation, it's not pressure, children, it's pressure difference. It's not height, it is change in height. Then what? The density into gravitational field strength, right? So we'll write in the words how the question says. Pressure difference is equal to the height multiplied by the density, then multiplied by the gravitational field strength. Okay, children, right. We'll move to the next question. The depth of fizzy water in the glass is 22 centimeters. The density of the fizzy water is 1080 kilogram per meter cube. Calculate the pressure difference at the bottom of the glass with the fizzy water. So it's simply substituting the equation delta P is equal to delta H rho G. So delta P, to find, I'll substitute the height. 22 is in centimeters, SI unit of length is meters. So to convert centimeters to meters, I might divide by 100 and then multiply by 1080. Gravitational field strength for IGCSE specification, you take it as 10. So we'll just get the answer and see how it goes. Okay. Alright. So it's 22 divided by 100 multiplied by 1080 multiplied by 10, which will be equals to 2376. 2376. Okay. Right. Next question. Calculate the pressure of the gas in the bubble when the bubble is at the bottom of the glass. Atmospheric pressure is 101,000 pascals. Here it's a simple equation to use. The total pressure, the gas, the bubble, the gas bubble does not understand a liquid pressure or a atmospheric pressure. It will feel a total pressure. The total pressure is what matters. To find the total pressure, this equation, the liquid pressure plus atmospheric pressure. So do we know the liquid pressure? Yes. Do we know the atmospheric pressure? Yes. Then just substitute and get the answer. The liquid pressure we found previously 2376. Atmospheric pressure is 101,000. So when you add these two numbers, you get 101,000. I get the answer as 103,376. So the answer we get is 103,376. Okay, children. Right. Moving to the next question. When the bubble is at the top of the glass, the pressure of the gas in the bubble is equal to 101,000 pascals, and the bubble has a volume of 0.084 centimeter cube. Calculate the volume of the gas in the bubble when the bubble is at the bottom of the glass. Assume the temperature of the gas remains constant. When they say the temperature remains constant, you have to understand this is related to Boyle's law. So on Boyle's law, you have learned that the mass of the gas is constant and the temperature of the gas is constant. The pressure is inversely proportional to the volume. So we have equation P1 V1 equals P2 V2. So directly substituting that equation, what? You can get the answer. Okay, children? Right. A second. Okay. Substituting the equation. So I'll get the P1 as 101000. V1 volume initial 0.084. P2 the pressure afterwards is 103376. That is the pressure we found here. Can you see, children? I'll mark it with green color. Can you see the green color arrow, children? So that is what which has to come here. So multiplied by, right, I've already written that expression here. So can you see that I've written the 10376, right? So then multiplied by the volume V2. V2 is unknown. So V2 is equal to, I take the 103376 to the other side of the equation, 101000 multiplied by 0.084 divided by 103376, isn't it? 103376. So simply we enter the sum on a calculator and we'll try to get the answer. So it's 101000 multiplied by 0.084 divided by 103376, and we get the answer 0.0820. So if I write for three significant figures, I get 0.0821. Okay, so 0.0821. Okay, so we'll move to the next question. The photograph shows a toy car. When the toy car is pulled backwards, energy is stored in the elastic store as the rubber band is twisted. So you have to understand what they're saying is the energy is stored as elastic potential energy. Okay, so when the car is released, some of the energy from the elastic store is transferred to the kinetic store of the car. The remaining energy is transferred into the thermal store of the surrounding. So thermal store means what? We don't need to heat the surrounding, so that has to be a loss. So the useful type of energy here on this question has to be kinetic energy. State what is meant by the principle of conservation of energy. I assume you know these things, you have learned these things, right? So what does principle of conservation of energy mean? Energy cannot be created or destroyed. Can't be created or destroyed. It can only be transferred from one form to another. From one form, I can see it as one type also, to another. Okay, children, right? The car is pulled backwards, so there is 165 joules of energy in its elastic store. So what we have to understand is what does the question say? Is there any useful information? Okay, we'll see. So elastic store, so that is the initial starting energy, that's the total energy. You have to understand it's the total energy, right? When the car is released, the energy transfers to the car's kinetic energy store with the efficiency of 15%. So 15% is the what? Kinetic energy. State the formula linking efficiency, useful energy output and the total energy output. So that's a easy equation, children. So if I write it with words, it's efficiency, which is equal to useful energy divided by useful energy output divided by total energy input. Total energy output, right? So this is on a ratio. You can write in this way, or you can multiply by 100. If you multiply by 100, what you are getting is the percentage efficiency. Okay, children? Right. Moving to the next question. Calculate the energy transferred into the thermal store of the surroundings. So they're asking the how much is given out to the thermal. So what I understand is here the kinetic energy is 15%. Therefore, the thermal has to be 100 minus 15. So that will make the sum easy, I guess. All right. We'll try to continue with the rest of the question, children. So was it clear that 15%, if energy is lost as 15%, the rest has to be, I mean, if the energy given out as kinetic energy is, if it is 15%, the energy lost has to be 85. The way we do is this. So we have 100 100 minus 15, which is 85%. Okay, so 85% is given out as a wasted energy, right? Oh, that is the thermal, isn't it? Right. So I can write it as 85 is equals to thermal energy divided by total energy into 100%. So we know the total energy in this question, right? So the total energy is there as elastic potential energy. When started the question, they have already said that. So can you see? So we know the what? Total energy. So then just substitute in the sum, you'll get the answer. So I can write it as 85 is equals to, I'll write E thermal divided by 165 into 100. So I get the E thermal, which is equals to 165 into 85 divided by 100. So we'll enter on the calculator and see what the answer is. So I'll get 165 multiplied by 85 divided by 100. I get the answer as 140.25. So the answer here has to be 140.25. So without doing on this method, there's another method you can do. You can find the energy given out as kinetic energy. So with substituting 15%, then from the total energy 165, you can subtract that amount which was given out as kinetic energy. When you subtract, it will give the energy given out as thermal energy or the loss of energy. Okay, children? Right. Move to the next question. Draw a label Sankey diagram for this energy transfer. So Sankey diagram is a diagram which shows the total energy and the different types of energy given out, right? Assume the total energy is this much. So assume out of that what? Sum of the energy is given out as thermal energy. Very small amount of energy is given out as kinetic energy. Kinetic energy is thermal. So how much is given out as thermal energy? It's 85 joules, 85%, right? and kinetic energy, it's approximately, yeah, it's 15. So when you draw this diagram, this has to be there. Next thing is, children, you have to, when you, it's a masked on a Sankey diagram, when you draw these Sankey diagrams, the ratio, you have to consider the ratio. So this ratio, I'll say this height as x and this height as y. So x is to y, the ratio has to be equals to 85 is to 15. So I assume you know how to work out with the ratios. So I'll just divide 85 by 15. So I get the answer as 5.666. So 5.66 is to 1. So x, if I take y with 1 centimeter, x has to be 5.66 centimeters, children. So that is expected on a Sankey diagram. Okay, right. Moving to the next question. The car is pulled backwards again. So this is the types of energies. Thermal energy is there, kinetic energy is there. Starting type of energy is what? Elastic potential energy, right? Okay, all right. Moving to the next question. The car is pulled backwards again. When released, 45 joules of energy is transferred to the car's kinetic store. So is it the useful type? Where's the type? Our objective on this question, this equipment is to make the car move. So 45 joules is a useful type of energy. You have to understand that. The car travels a distance of 7.5 meters during this energy transfer. State the useful work done by on the car. So simply, the question already said the useful type of energy, and you can see it's a 1 mark question, right? So it's 45 joules. Okay. Calculate the mean accelerating force acting on the car. So it's not asking the acceleration, they are asking the force, right? Right. So you know these equations. Work done is equals to force multiplied by distance moved in the direction of force. Substitute into that equation, you get 45 here. You don't know the force. The distance is given in meters, 7.5. So F will be equal to 45 divided by 7.5. We'll use the calculator to get the answer. 45 divided by 7, I'm sorry, 45 divided by 7.5, which is 6 newtons. 6 newtons. So they have given the unit as newtons. What you have to do is, what? You have to write the answer 6 there. Okay, children? Right. So when you get the answer, write it at the blank they have provided us. Right. We'll move to the next question then. The diagram shows a device called a hydraulic lift. So the hydraulic consists of a tube of oil with a piston at each end. So you can see a piston X and piston Y. Smaller piston has to be the input piston. The larger piston has to be the output piston. Because what we are doing is using liquid pressure, applying a smaller force as an input, and we are going to get a larger force as output, right? Right. So this has to be the input, and this has to be the output. Right. Calculate the pressure difference between the bottom of the piston X and the bottom of the oil. So I'll mark this point as A, as this point as B. So what they're asking is PAB, right? It's a pressure difference due to a liquid, right? So simply H rho G. So height is how much? 57. 57 what? Centimeters. So centimeters, to convert into meters, you have to add to 100. Density is 820. The question has said that it's 820, and gravitational acceleration will be 10. So we'll simply get the calculator and get the answer. So we have 57 multiplied by 820 multiplied by 10 divided by 100. So we get the answer as 4674, 4674 pascals. Okay, so 4674 pascals. Right. So better we write the answer in the space they are provided. 4674 pascals. Okay, right. A 24 kilogram mass is placed on piston X. Calculate the weight of the 24 kilogram mass. Give the unit. That's a very easy question, children. W is equal to mg. Just a simple equation. F equals ma has got converted in terms of weight, and gravity if we consider as W equals mg. So mass is 24 kilograms. Gravitational acceleration is 10. So you get the answer as 240. What's in it? Newtons. So here we'll write the answer 240, and here we'll write the unit newtons. Okay. Calculate the extra pressure on the oil due to the mass. So we found the force, which was 240. Calculate the extra pressure on the oil due to mass. So extra pressure is given at piston X or Y. It's at piston Y because the vehicle is lifted at point Y, right? That's the place where we get the output. Input is the place where the person is pushing. So we'll see the cross-section area. Cross-section area at piston Y is 4.8 meters square, right? Okay. Calculate the extra pressure on the oil due to mass. "24 kilogram mass is placed on piston X." I'm sorry. The 24 is placed at piston X. So you have to find the pressure caused by the mass placed at X. So the mass is 24. So the force is 240. So the cross-sectional area we have to consider is 1.2 because they have given the question as the mass is placed at piston X, right? So the extra pressure is due to the additional mass placed. So the force is 240. The cross-sectional area is 1.2 meter cube, right? Right. So we'll give a try. 240 pressure is equal to 240 divided by 1.2 meter cube, isn't it? Right. You get the answer as 1.2. So 240 divided by 1.2. We get the answer as 200 pascals. So where do we write the answer here? The oil transfers the same extra pressure on piston Y. Calculate the force acting upwards on piston Y due to the extra pressure. So you have to see that point A, I'll mark this point as point D. Pressure at point A and pressure at point D has to be the same because it's the same liquid. It's a liquid from A, B, C, D. A, B to A, B, D, the whole thing is filled with a liquid. So if it is a liquid, you can say the theory that if the same liquid at the same level, the liquid pressure is same, right? So can you see that they are of the same level? Yes. So same liquid, same level, pressure is same. Therefore, we'll use that there. So the pressure was 200 at that point. So at point Y, closer to the piston Y also, the pressure has to be 200. So we'll substitute 200 is equals to the force at point Y, we don't know that, divided by the area of cross section. Area of cross section is 4.8 meters squared for piston Y, right? So it's divided by 4.8 divided by 4.8. So I get Fy is equals to 200 multiplied by 4.8, 4 to 80, 96. It has to be 960, I guess. We'll just check with the calculator also. 200 multiplied by 4.8, it's 960, right? 960. And 60 newtons. Okay, children. Right. Piston Y starts at rest, rises slowly, and then comes to rest. So starts at rest, then comes to rest. Starting also it's at rest, final also it's at rest. State how the following energy stores have changed from before the motion to after the motion is complete. Gravitation potential energy of piston X. So when you place a mass at point X, what happens is the piston X will move downwards, right? So piston X will move downwards, piston Y will move upwards, right? So when the object moves downwards, Gp is lost. When an object moves up, vertically up, Gp is gained. So piston X, the gravitation potential energy decreases, and piston Y, I can say the gravitation potential energy increases. Okay, children? So overall, if I talk of this is a decrease. Decrease, increase. On a hydraulic jack, there's no chemical reaction occurring or anything occurring, so there's no change. Chemical energy does not change. Kinetic energy of piston Y. Initially also it was at rest, finally also it was at rest. So overall change is just no change. Even though in between the energy changes, they are asking the question from the start to the end only. So hope you understood, children. Question number 5. Diagram 1 shows an hydroelectric power station. So there's some water in the upper lake which goes through the tunnel, and it shows the direction of water passing point X. It's falling down a vertical height of 45 meters and hits the turbine. When it's the turbine, it makes the turbine rotate and producing electricity as the generator. With the transformer, it is given to the national grid. Okay, right. Water falls from the upper lake and passes the position X in the tunnel. After falling to position X, 1.25 kilograms, 1.25 into 10 to the power 3 kilograms of water has 3.2 into 10 to the power 5 joules of energy in its kinetic store. Calculate the speed of the water at position X. They have already given the equation. You don't need they don't need to give the equation. It's a simple equation, children. You have already learned this, right? So K equals half mv squared. So kinetic energy is 3.2 into 10 to the power 5, half into mass is 1.25 into 10 to the power 3 into v square, right? So you can simply substitute and get the answer. You can make v the subject. When you make v the subject, v is equals to 3.2 into 10 to the power 5. Now this whole thing is a multiplication. When you take a multiplication to the opposite side, it becomes a division, right? Half into 1.25 into 10 to the power 3. Okay, children? So this is v squared. So when you get the square root of that will give the value of v. Okay, children? Right. So we'll enter and get the answer. .2 into 10 to the power 5. I'm sorry. 10 to the power 5, this is how you enter. 5. 10 to the power 5 into 3.2, you get the answer. That has to be divided by 1.25 into 10 to the power 3 into half, right? Okay, half is 1 divided by 2. Multiplied by 1.25 multiplied by, that's the easy way of doing this. You can do it with your calculator, children, but for the easiness on this computer, I'll do it in this way. So it's 0.5 into 1.25 into 10 to the power 3 is 1000, right? I get answer. I get the reciprocal of that. Multiply that by 3.2 into 10 to the power 5. I get some answer. When I get the square root of that answer, I get 22.62, 22.63, isn't it? So it's 22.63. Right, moving to the next question. Water with a mass of 1.25 10 to the power 3 kilograms falls through a height of 45 meters from the upper lake to the turbine. Calculate the decrease in gravitational potential energy store of the water between the turbine, upper lake and the turbine. Between the upper lake and the turbine. So it's again delta GPE. Delta GP is equal to mg delta H. Okay, children. So mass is given 1.25 10 to the power 3. Gravitational acceleration is 10. Height is how much? 45, right? So we'll enter the numbers and see what answer we get. So we have 10 multiplied by 45 multiplied by 1.25 into 10 to the power 3. You can enter 10 to the power 3, but I understand 10 to the power 3 is 1000, so I multiply by 1000. I get 562,500. 562,500. That's energy in joules. State how much work has been done on the water by the earth. You can see that's a 1 mark answer. It's obviously the work is done by actually the earth for the object to move down. So the same answer right here, which is 562,500 joules. Next question is, what is energy? That's an easy question, children. You know, is the ability to do work, or you can say it's the amount of energy an object would have. The amount of energy is what it will, the amount of work an object would be able to do is the thing what we say it as energy. It's the ability to do work. Right. State the formula linking total energy output, useful energy output and efficiency. So this we have already discussed. The efficiency is equals to the useful energy divided by the total energy output. Useful energy output is total energy output. If it is just efficiency, you can say it that way. If they say percentage efficiency, you have to multiply by 100. Okay, children? Right. Diagram 2 shows Sankey diagram for the generator in the hydroelectric power station. The generator is designed to transfer electrical energy to the transformer. 320 joules of energy is given mechanical by water. 278 kilojoules is given energy transferred electrically by the generator, then 50 kilojoules energy transferred mechanically by the generator. So if it is a generator, hydroelectric power station, our requirement is to produce electricity. So what you have to understand, this is the useful, this is the wasted, and this has to be the total. Right, we'll see what the question is asking. Which of these correct expressions, which of these is the correct expression for calculate the efficiency of the process shown in diagram 2? So the efficiency will be equals to the useful energy divided by the total energy. The total energy is 320 multiplied by 100. So you get the answer as answer B. Okay, children? Right. Moving to question number 6. The diagram shows a manometer, a device used for measuring difference in pressure. One side of the manometer has trapped gas, the other side is left open to the atmosphere. So left side you have trapped gas, the right side is what? Left open to the atmosphere. The difference in pressure can be calculated using the formula difference in pressure is equal to height into density into gravitational field strength. So they are asking the density, they say in the question that the density of the liquid is 1.3 in 10 to the power 4 kilogram per meter cube. The difference in the levels of the liquid is 3.8 centimeters. Okay, this is 3.8. That means to calculate the difference in pressure between the atmosphere and the trapped gas. So it's simply the change in the heights of the liquids what matters for the pressure difference between the two air columns. Delta P is equals to delta H rho G. So the height is 3.8. Again, this is also given in centimeters, so you have divide by 100, convert into meters. The density is 1.3 into 10 to the power 4 multiplied by the gravitational acceleration. Right? We'll enter this on the calculator and see what the answer is. So it's 1.3 into 10 to the power 4 multiplied by 10 multiplied by 3.8 divided by 100. We get the pressure as 4940 pascals. Okay, children? Right, they have given pascals in the question. The temperature and the pressure of the trapped gas increases when it is warmed. The pressure of the trapped gas in the manometer is 9.95 10 to the power into 10 to the power 4 pascals and the temperature is 16 degrees Celsius. Calculate the new pressure of the trapped gas if the temperature increases 32 degrees Celsius. Assume the volume of the trapped gas remains constant. So the temperature, according to the temperature, the pressure changes, the volume remains constant. So the equation to use is P1 over T1 is equals to P2 over T2. So you have to understand that the letter, it's not simple T, it's capital T. So simple T will write for usually for time, but in this lessons we write it for Celsius temperature. But you have to understand that capital T means it has to be in what, children? It has to be in Kelvin temperature. Okay, right. So divide by T2. So they say 9.95 into 10 to the power 4 divided by the temperature in Celsius 16. So 16 plus 273 to convert into Kelvin. You don't know the pressure. That's a thing what you have to find, the new pressure. The temperature has gone to 32 degrees Celsius, right? 32 plus 273. So the way you do is P2 is equals to 9.95 into 10 to the power 4 multiplied by 32 plus 273 divided by 16 plus 273. Okay, children? Right. So we'll get the calculator and get the answer. So 32 plus 273, I'll get the answer that's 305. So instead of this, I can write it as 305, right? It's 305. And 16 plus 273. 16 plus 273, which will be equals to 289. So instead of this, I can write 289, right? Okay, we'll use the calculator and try to get the answer. So 305 divided by 289 multiplied by 9.95 into 10 to the power 4, and I get the answer as 105,008. So the approximate answer I can write as 1.05 into 10 to the power 5, isn't it? 1, 2, 3, 4, 5. Yeah, 1.05 into 10 to the power 5. Okay, children. Right. On to the next question. The photograph shows a truck with a crane that is used to move large bags of building materials. Okay, state the formula linking work done, force and distance moved. So work done is equals to force multiplied by distance moved, isn't it, children? So W is equal to F into D. The force into distance moved in the direction force, to tell it precisely. So a bag of building materials has a weight of 8750 newtons. Calculate the work done on the bag when it is lifted a vertical distance of 230 centimeters from the ground until it is stationed again. Give the unit, right? So they have given the force 8750, distance is 230, which is in centimeters, so you have to convert it into meters by dividing by 100. So we'll do this question, children. It's 8750 multiplied by 230 divided by 100. You get the answer as 20,125. So the answer you get is 20,125, and that has the answer has to be in what unit, children? The work done or energy is measured using what unit, children? It has to be in joules, right? Right. So we'll write the answer in joules. Right. So the marking scheme shows us the answer also. Check the marking scheme also. So check the marking scheme. It's 50 multiplied by 2.3. The answer you get is 20,125. Right, we move to the question. Right. 20,125. $20,125. The unit is in joules. The crane takes 7 seconds to lift the bag. Calculate the mean power output of the crane when it is lifting the bag. So power is equals to energy or the work done divided by the time. Okay, so energy or the work done is 20,125, and 20,125. Time taken is 7 seconds. So simply divide this by 7. 20,125 divided by 7. And I get the answer as 2875. 2,875. 2,875 watts. The truck has a stabilizing leg which is positioned on a wooden board. Give a reason why the wooden board is used. So can you see that the wooden base board has a higher surface area compared to the stabilizing leg? So what you have to say is, when you apply the equation pressure equals force of area, when the area increases, the pressure decreases. So what you have to say is what? Wooden board has a higher area, higher surface area in contact, so decreases the pressure. So the stabilizing leg will not sink in the ground. Okay, right. So write that. Next question. State the formula linking pressure, force and area. So pressure is equals to force divided by, actually it's a perpendicular area. Okay, even though they don't say it, you have to understand it has to be the perpendicular area, right? So the wooden board is a square. I'm sorry about the spelling mistake, children. It's a square with side length 0.5. So if you have a square of 0.5, so the area of that will be 0.5 into 0.5, right? Right. So they are asking the force. Pressure is equals to force over area. Do you know the force? Yes, they have said in the question, which is 148 kilopascals. 148 kilopascals. So which is 148 into 10 to the power 3. The reason we multiply by 10 to the power 3 is to convert kilopascals to pascals, right? Force is unknown. Area is 0.5 into 0.5. So I can write the answer as F is equals to 148 into 10 to the power 3 multiplied by 0.5 into 0.5. We'll try to get the answer. So I'll start with 0.5. 0.5 multiplied by 0. I'm sorry, children. 0.5 multiplied by 0.5, which will be 0.25. I multiply that by 148 into 10 to the power 3. So I get the answer as 37,000 newtons. Newtons. Hope you understood, children. If you have any confusions, any doubts, please ask me. Have a nice day, and I assume that all of you will be able to get good marks and do your exam very well. Have a nice day, children. Bye bye.